Good morning, students. Previous session we completed shading, animation, gaming platforms, and today's session, the last session for Unit 5, we are going to complete OpenGL part. Introduction to OpenGL. The question can be asked on this, like what is OpenGL? Explain in brief the libraries supported by OpenGL. So that can be explained like this. OpenGL, that is Open Graphics Library, is a standard specification defining a cross-language, cross-platform application programming interface, that is API, for writing applications that produce 2D and 3D computer graphics. I'm again repeating. Open Graphics Library is a standard specification defining a cross-language, cross-platform application programming interface, that is API, for writing applications that produce 2D and 3D computer graphics. The interface consists of over 250 different function calls, which can be used to draw complex three-dimensional scenes from simple primitives. OpenGL's main purpose is to render 2 and 3-dimensional objects into a frame buffer. OpenGL is a low-level procedural application programming interface requiring the programmer to dictate the exact steps required to render a scene. In its basic operation, OpenGL accepts primitives such as points, lines, and polygons, and converts them into pixels via graphics pipeline known as the OpenGL state machine. Most OpenGL commands either issue primitives to the graphics pipeline or configure how the pipeline processes these primitives. This figure shows the block diagram of OpenGL data processing method. The commands enter from the left and proceed through a processing pipeline, as shown in this figure. Some commands specify geometric objects to be drawn, and others control how the objects are handled during various processing stages. The processing stages in basic OpenGL operation are as follows. First block, that is display list. Rather than having all commands proceed immediately through the pipeline, you can choose to accumulate some of them in a display list for processing it later on. Then next we are having evaluator. The evaluator stage of processing provides an efficient way to approximate curve and surface geometry by evaluating polynomial commands of input values. Then primitive assembly. OpenGL process geometric primitives, points, line segments, and polygons, all of which are described by vertices. Vertices are transformed and lit, and primitives are clipped to the viewport in operation for rasterization. Next block we are having, that is rasterization. The rasterization stage produces a series of frame buffer addresses and associated values using a two-dimensional description of a point, line segment, or polygon. Each fragment so produced is fed into the last stage per fragment operations. In per fragment operations, these are the final operations performed on the data before it is stored as pixels in the frame buffer. Per fragment operation include conditional updates to the frame buffer based on incoming and previously stored Z values for Z buffering and blending of incoming pixel colors with stored colors, as well as masking and other logical operations on pixel values. Data can be input in the form of pixels rather than vertices. Data in the form of pixels such as might describe an image for use in texture mapping skips the first stage of processing described above and instead is processed as pixels in the pixel operation stage. The pixel data is either stored as texture memory for use in the rasterization stage or rasterized, with the resulting fragments merged into the frame buffer just as if they were generated from geometric data. In this way, this block diagrams explains OpenGL data processing methods and introduction to OpenGL. Then after this, we are having functions and features of OpenGL. Question can be asked, what are the different functions and features of OpenGL? So let's first start with the functions of OpenGL. There are many functions provided by OpenGL for graphics system. Some of the important graphics functions of OpenGL are first, display list, feedback, alpha bending, pixel operations, texture mapping, color index mode, polynomial evaluators. Let's talk with the first, display list. The contents of display list are processed and executed more efficiently than the same set of OpenGL commands executed in immediate mode. Second, feedback. This is the mode where OpenGL will return the processed geometric information to the applications as compared to rendering them into frame buffer. Next, alpha bending. It is used to create transparent objects. Fourth, pixel operations. There are different operations. Fourth, pixel operations. There are different operations carried on pixels such as storing, mapping, zooming, transformation, etc. Texture mapping. It is used to create realistic effects in images. In this process, we are applying different graphics primitives on images. Sixth, that is color index mode. Instead of storing the values of RGB component colors, color buffer stores color indices. And last, that is polynomial evaluators. It supports NURBS, that is non-uniform rational B-spline. In addition to above functionality, OpenGL offers following some of the important features also. First feature is scaling and rotation. Second, performance. Third, transparency. Fourth, alpha bending. Fifth, rendering in 3D. Sixth, primitive operations. And last, seventh, that is hardware. Let's talk of all these features one by one. First, scaling and rotation. The transformations like scaling and rotation can be achieved very easily without any problem. Second, performance. Higher level performance is achieved when OpenGL is used on an accelerated device. Third, transparency. We can make some portion of the graphics as a transparent area with the help of OpenGL. Fourth, alpha bending. It allows graphics to be drawn semi-transparently. Fifth, rendering in 3D. OpenGL offers ability to render 3D graphics. By using OpenGL, we can draw the objects which are away from the user as smaller as compared to the objects which are near to viewer. Sixth, primitive operations. OpenGL provides basic drawing primitive operation such as point, line, polygon, etc. with the help of which you can easily draw point, line and polygons. Seventh, hardware. Whenever the speed of operations need to be increased, OpenGL use hardware. So that was all about features of OpenGL. This is what the sample program of OpenGL. We require to include in the C program some of the graphics libraries. The first graphics library, that is GL, that stands for graphics library. Second, GLU, that is graphics library utility. And next, GLUT, that is graphics library utility toolkit. And as this is our C program, we have to include stdio.h also. This is a sample program for drawing a line from the specified points, start point to end point, and printing one word or statement in graphics mode, in graphics output mode. We are taking here this global variables integer x and y. Then init method, which initializes the graphics output window. The clear color screen is going to set by with color RGB as 111. The GL color 3F is going to set with the inside background color, that is 000. GL viewport, that is maximum height and width of your view, that is window. GL matrix mode, that is whether you are going to use which projections for showing your object, that is GL projection. And GL load identity, that is loading the identity matrix. Glue ortho 2D, that is you are going to map a graph of 640 by 480 with maximum x and maximum y. So that is all related to initializing the window of graphics. Next, this is the method function which is going to print a string or character. So void render bitmap string. Here we are having float x, float y, and character pointer to the text. Float x and float y will decide the location at which that particular string or that word is going to print. Then GL raster position 3F, you are going to initialize the position of rastering that or designing that particular string. For C is equal to text and then pointer C not equal to /0 and C++, we are going to get each and every character in the string one by one except the last null character. Then we are going to call this inbuilt method, that is glut bitmap character, which uses a rendering method for printing, for rendering that particular character, that is bitmap. So glut bitmap times Roman, that is what the font and the size which we are going to print for that characters, which is stored inside character pointer C. Draw function is going to display what we are going to get at the output screen. We are having one more character pointer text here inside this function, which is equalized, which is equal to skncoi. The background color is set at with 0, 1, 0, that is green. The GL color will going to clear the output of the previous window, previous executions. Then we are going to have one loop, that is GL begin and GL end, with the help of basic graphics primitive, that is GL underscore lines. Inside this GL begin and GL end, we are having GL vertex 2y, that is drawing vertex with the help of graphics library, which is in 2 dimension and which is takes input as integer from the point 10, 10 to 100, 100. It means that we are going to draw with the help of basic graphics primitive, that is line, from 10, 10 to 100, 100. And as well as we are going to print the skncui string. Then next, this GL begin and GL end, we are also going to draw the lines which are getting the mid of x and mid of y, and with the help of that we are going to divide our screen into 4 equal screens, one exactly horizontal line and one exactly vertical line. The next GL begin and GL end, we are going to have basic graphics primitives, that is GL underscore points, where we are going to have that vertex at position xy. Then we are going to call our render bitmap string function at 200, 200 location, that is x 200, y 200, and the text which is initialized in text is get printed, that is skncui at location 200, 200. And at the last we are going to free all the memory used by the inbuilt functions of graphics libraries, that is GL flush. It flushes all the memory used so far. Then we are having our main function. We are going to print the statement, enter the value for x and y, that is getting scan inside x and y. Then glut init will initialize the graphics drivers and graphic modes. Glut init display mode will get the values of glut single and glut RGB, that is we are going to draw our 2-dimensional object in simple RGB mode and in single mode, which doesn't have any animation. Then next we are having glut window position and glut init window size, that is going to set the initial window position and size as 00 and 640 to 480 respectively. the position is at 0 0, and the size of the window is 640 comma 480. The maximum x is 640 and maximum y is as 480. The next we are having sample program which going to give an output window with name as Bresson circle here, and init method will initialize that output window. Group display function we are going to call the draw function, which is going to render that line and that string SKNCU, and this all going to persist there. For persisting it, we are going to have glute main loop and lastly return 0. And this is what the output we are going to get here. We are getting one dot here at x and y, which we are going to scan. We are getting one string, that is SKNCOE, and we are getting one basic graphics primitive lines, that is one line from 10 10 to 100 position, as well as we are getting one horizontal and one vertical line which is going through exactly mid of x and mid of y, which divide your screen into 4 quadrants. So that is what the first sample program output of OpenGL using basic graphics libraries. The next program which we already completed in practical execution, that is DDL line drawing program using OpenGL. Here also we are going to use standard input output header file, that is your C program, so that's why include stdio.h. Then we are going to use some inbuilt functions from math, so hash include math.h. After this we are having graphics library utility toolkit header file, then graphics library utility header file, then graphics library header file. We are going to have double variables x1 y1 x2 y2 from which we are going to draw line. We are having one round value function which is going to round the value which taken as input to float v. So it will return the floor v plus 0.5. By adding 0.5 it is going to round the values. Then we are having this line DDA function which first calculate the differences of x values and differences of y values, that is x2 minus x1 and y2 minus y1. We are having one variable which calculates steps. Then we are having some few variables x increment, y increment, xy, that is starting of line get initialized to x1 and y1. For finding out whether to increment x or y, we are going to have that value of steps depending on whether dx is greater or dy is greater. If dx is greater, the steps is equal to dx, and if dy is greater, the steps is equal to dy. Depending on that, we are going to calculate values of x increment and y increment. So x increment will be calculated by formula x increment is equal to dx by steps and y increment is equal to dy by steps. Then clearing the buffers to preset values, we are going to call grepclear function. Then this function continued here. In GL begin, GL points and GL end, we are going to plot here the first point, that is GL vertex 2D, with the first starting position value as x and y. Then with the help of this for loop with variable counter variable k, for every step we are finding an intermediate vertex from starting x1 y1 to the end x2 y2. With this for loop we are going to calculate the x plus y plus by adding x increment and y increment respectively in it, and we can have the printf values of x and y also, which we have calculated by rounding off by calling floor function, which is we have defined earlier. GL vertex 2D will plot that round values of x and round values of y and proceed to the end point, that is x2, y2, and we are going to end GL end. So GL begin, GL end, we are using basic graphics primitive, that is GL points. It means that we are going to draw a line by using basic graphics primitive GL points. Lastly, we are going to release all the memory allocated by graphics libraries in build function. So that's why we are going to call GL flash. It releases the memory used by all graphics library functions. Then we are having some functions related to our graphics output window, that is init, which is pretty much same to the previous function. Here we set the color to the white background color with GL clear color 1.0, 1.0, 1.0 and alpha as 0, that is transparency factor. Next, we are having set fill color to black. The line which we are going to draw, that is four color of the objects which we are going to draw, that is with 0.0, 0.0 and 0.0, that is RGB value set to black. Viewport matrix mode GLOAD identity is not required as we are not using animation or 3D object rendering. So directly we are going to use glue ortho 2D, that is maximum x and maximum y for the graph which we are initializing on your graphics output window. So with this initializing of graphics output window, next we are having our main function. So first we are going to print here, enter two endpoints of the line to be drawn. Then that we are going to scan in x1 and y1. And second point we are going to scan in x2 and y2. Then we are going to call a glute init function that will initialize the graphics drivers and detect the graphics mode supported by your graphics output devices. Then setting the initial display mode to glute single and glute RGB. Then setting the initial window position and size of output window screen, that is position to 00 and window size to 640 and 480. Then we are calling our glute create window with the title as BDA underscore line. We are calling init function to initialize the drawing colors and all details parameters of output window. Then calling the display function. In display function, we are calling our line DDA function. And for displaying until the program is closed, we are going to call lastly glue to main loop. And with this, we are getting the output, that is line drawn from x1 y1 to x2 y2, which we already completed in the first assignment, that is DDA line drawing using polygon. So this is all for today's session and introduction to OpenGL, their functions, their features, and block diagram of OpenGL data processing method. Here we are going to end and complete our unit 5, that is shading, animation, gaming, and last point OpenGL. So this is all for first session. Thank you. We will stop here.